This is Geometry Semester 1. It's the 7th unit called Congruence, and it's the second lesson called SAS, which stands for Side Angle Side Congruence Postulate Practice. It's on creatormath.com under the Geometry tab. You might have to Google creatormath.weebly.com to find the site. The instructions are copy the following problems into your composition book on the correct pages according to the table of contents with the notes for those pages from creatormath.com. So before we get into the problem set, let's try to show the website and how to find those notes. So this is the address, creatormath.weebly.com. Google that and hopefully you can find it. You're going to look for the home page, looks like this. Everything you need to know about your composition book, because a lot of students are continually asking questions about how do I fill out the composition book. Scroll down on this home page and find the large words composition book, the picture, and then follow all these videos, deadlines, and instructions. Right? If you're filling that sucker out right, you're going to have a 90 to 100% on that, and it should be a grade booster for you. And the notes are important to help you do these problem sets we're going to do here. So now I'm going over to the Geometry tab. All of the notes, video, lessons, problem sets, and even vocabulary is under the tab of the class you're in this case Geometry. So here is the Vocabulary Geometry Practice Study PDF. If you open this PDF, you can search it and it will bring up, it has all the words, vocabulary words we use for geometry for the entire school year. And it is searchable too. All right, download that to your device. Google how do I search it using whatever kind of device you have. It's a little bit different for each device. So now I'm going to find the table of contents for the proper semester for the lesson I'm doing right now. This is it here. It says Geometry Table of Contents. You should have already written this entire table of contents on the pages 2 through 6 of your composition book. It takes up about 3.5 pages. It takes probably 30-40 minutes to do, but you do it once at the beginning of the semester. Now you know the page numbers for everything that goes in the comp book. We're scrolling down to the proper unit. In this case, it's congruence. This one is the second lesson. You'll see the number of lessons here. 5 lessons. We're on number 2. This one is side angle side, or SAS Congruence Postulate. Here are the page numbers where these notes go on in your comp book. Please don't look at this video for the page numbers, but go reference the original table of contents on the website, because by the time you watch this video, these page numbers will probably be different. So click Notes. Fair warning, sometimes I have to open this twice to get it to load. It did load this time. You should be able to expand it. If you can expand it, then it's loaded. It's going to talk to you about SAS, side angle side, congruency postulate. Given 2 triangles with 2 pairs of corresponding sides with equal lengths and equal included angles, they are congruent. So you're going to put that in your notes. You're going to have a couple of examples. Remember that these drawings will not be drawn to scale. They will purposely be drawn out of scale to test your knowledge of the congruency postulate you're using to say if these two are congruent. Now, just a quick review. Congruent means equal. We use congruency in geometry. The way I explain it is congruency is multiple aspects of equality. So it's not just all the angles of a triangle being equal to each other. It's the side lengths also being equal to each other. So you're talking about multiple aspects of equality, not just one side, but this side equal to this side equal to this side, the corresponding sides equal length to each other. So congruency means exactly equal or the same shape and size and shape in geometry. All right, so are these congruent? Why? Well, so let's look at what we got here. This one's an obvious example. They're going to make it easy for us. This one's got 2 tick marks, this side length, so match it up with this one, 2 tick marks. Then there's an included angle here with 3 tick marks equal to this one. And then there's a side off after that with 3 tick marks and 3 tick marks. So we might have to flip this one, this DEF, to see how it actually lines up exactly, but we can see a 2 tick mark, a 3 tick mark, and a 3 tick mark in that order, a 2, a 3, and a 3 in this order, and that order tells us side angle side. So these two are congruent. They are exactly the same size and shape, and what we have to prove it is side angle side congruency postulate. That's the definition we're applying to say that these are done to scale. So let's look at this one here. Here's a side 5, here's a side 5. Here's a side 12 and a side 12, and so those sides are equal lengths. Notice the included angle between the 5 and 12 is one tick mark here and one tick mark here, the one between the two side lengths. So this would be side angle side, and that matches up with side angle side of corresponding. Again, the word corresponding means this side 5 is in the same place of the shape as this one, but on a different shape, right? So these two sides correspond to each other. Now I know this triangle's been rotated, but if we took this one and rotated it around so that the 5 was here, the 12 would be down here, and the included angle would be right here. So you might have to rotate the orientation of one of these triangles to get it to match up with the first one. Are these congruent? Yes. SAS Congruency Postulate is our reason. So if we have two triangles with two equal corresponding side lengths and equal included angles, so this angle is called included. So there's two side lengths and the included is between the side lengths. Same here. So that's what that called. And the included angle, side lengths equal and equal included angle, the two triangles are exactly the same, otherwise known as congruent. Now, just to give you some perspective, the opposite, maybe so to speak, of congruent is similar. Similar means proportional, same shape but different sizes. That's where we break out the model of the Augusta A109 helicopter, right? This is a 1/43rd scale model. This would be similar in geometry, and it's a very specific word. It means proportional. A scale model means if we blew this up to the full size of the helicopter, it would look exactly like the real thing. Fair enough? So we brought that out before. We've talked about proportional before, but just to remind you, in geometry, the word similar means proportional. It's the same shape, but different size shape. Okay? Here's the symbol for congruency. It's an equals with one squiggly on top. Here is the symbol for similar or proportional. It's one squiggly line. The included angle is that angle between the two sides, as we pointed out. Congruent means equal corresponding angles and equal corresponding side lengths, so multiple aspects of equality. Corresponding means matching locations on different shapes. Here are some problems you're putting into your comp book, and you're going to solve those if you can. Now we're going to move on to the problem set and see if we can work through these. So first things first, what does congruent mean? So in geometry, congruent means more than equality, equal corresponding angles and equal corresponding side lengths. And that's a little bit, not a perfect definition, but good functional definition for you to understand that if two shapes are congruent, they're exactly the same size and shape. What does proportional mean? Proportional means one is larger, one is smaller, but otherwise they're exactly the same shape, just like our helicopter. It's the exact same shape of the real. It's just a different size. So that's what proportional means. It means they are different by a scale factor. So this is larger or smaller by a scale factor. And remember, our model helicopter is 1/43rd the real helicopter's size. So if you took every piece and every part and every dimension of the real helicopter, divided it by 43, it would look exactly like that model. All right, what's the symbol for congruence? It's this one here. It's an equal sign with a squiggly over it. That means congruent, right? So you'll see us say triangle ABC is congruent to triangle DEF. You'll see that kind of notation, right? This means triangle. This is ABC, right? That defines which one it is, congruent to triangle DEF. What's the symbol for similarity? Let's move this up a little bit. So similarity is just a squiggly line. That means two things are similar or proportional. Proportional. All right, we love that idea, proportional. If you had a scale model, say you're an architect, you build up a scale model of the building you're designing or home, it would be exactly like, you can just look at it and see the actual, the way the one's going to actually look, but it's going to be a shrunken size, right, by a scale factor, a consistent scale factor. The following two shapes are congruent. So these questions aren't really questions at first. They're telling us these two are congruent. They're asking why. What postulate are you using? Well, this one's got a side equal to a side equal to a side, and another side equal to another side. This is side, side, side congruency postulate. So a little bit tricky because we already had this one in last lesson, so the first question they lead off with is a question from last lesson. So now we know two postulates, and there's the first one, side, side, side postulate, a congruency postulate. And we want to keep saying the full name, side, side, side congruency postulate. You can't just say side, 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 because we're going to get to similarity postulates too, that sound very similar in name. So we're going to keep saying the word congruency postulate. The following two shapes are congruent. By what congruency postulate are they congruent? By what congruent postulate are they congruent? All right, so, well, this looks like side, side, side to me. I don't see even any angles involved, right? So I know what we know so far, and if I laid this one down in the same orientation as this one, then I would have this here, and that would look like my three sides being equal to my three sides. All right, now, this one's equal to this one, but this one's equal to this one's equal to this one, and this one's equal to this one. So side, side, side congruency postulate. Again, a review from last lesson. All right, the following shapes are congruent. By what congruent postulate are they congruent? Drawing not to scale. Follow the markings. So we're looking here, 1 to 1, 2 to 2, and 3 to 3. So that's a side, 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 right? Pretty obvious at this point. It wasn't obvious when we first learned it, but now that you start to see this multiple times, maybe it gets a little bit more obvious. All right, they're telling us it's congruent again. They're asking us by what congruency postulate. Let's match up sides. Let's rotate this 180 degrees. It would look like this. The 5 would be here, and as we rotate it, the 7 would be here, the 12 would be down here. And it would be rotated, this would be a D, E, and an F. All right, so let's match up 5 and 5. Those are corresponding sides, here and here. The 7 and the 7, those are corresponding sides, and the 12 and the 12, those are corresponding. So far none of the new postulate yet. Let's keep going, see if we can find one. So this looks like the same thing too. If I rotated it down, right, the 5 would be here, this would flip over, the 8 would be on this side, and the 15 would be down here, right? 5 is corresponding to 5, 8 corresponds to 8, 15 corresponds to 8, side, 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 congruency postulate. Yes, they are congruent, and we proved it by that postulate. All right, this one looks like finally an example of our newest postulate here. They are congruent. What is the name of the congruency postulate? So now we have a side, an included angle with 2 tick marks, and another side with 2 tick marks. Look at this one. 1 tick mark matches here. Then the 2 tick mark angle comes after it, and then the 2 tick marks in the side comes after that. So if we just went through in this order and went through in this order, it would be side, angle, side. So this is the side, angle, side, or SAS Congruency Postulate. We have to keep saying congruency because some of these are going to match up with similarity postulates, all right? Just to give you a heads up of what's coming in the future. All right, these are not drawn to scale. They are congruent. What are we looking at? We're looking at an 8 and an 8, and as we go around, we see an angle that's equal to an angle, so go around. We see a side equal to a side. If you just took this and flipped it over, right, and did it like this, then we would have this exact same order. The 8 would come here, the 15 would come here, and this angle would come here. So we would go the same order. Notice 8, angle, included angle, and 15. This is a side, angle, side postulate, congruency postulate. All right. All right, let's see what else we got. They are congruent. It looks like a side angle side right off the bat. Let's see if we can rotate this. So I'm going to flip this around this way. Not flip, but rotate. That would make the D here, the E here, and the F here. D to E is 5. E to F, we don't know. E to F, we have no idea. But D to F, we have 12. All right, and angle D, we have 1 tick mark and 1 tick mark. So look, side, angle, side. Side, angle, side. 5, angle, 12, 5, angle, 12. This is side, angle, side, congruency postulate. All right, so we're going to circle that one. One more. Looks like an interesting case. Let's see this one. They're telling us again they're congruent already, so they're kind of warming us up to all this. The following 2 shapes are congruent. So it looks like we have a side, angle, side. It's 2 tick marks, 3 tick marks, 3, 2, 3, 3. These are congruent. Even though they're not drawn to scale, they look different sizes. These are congruent. These are exactly the same size and shape. So One of the most difficult things for students to do sometimes is make sure that they're matching the title of each video with the title of that set of problems that they're doing, okay? If you don't match it up, things don't look the same, right? This is Geometry, Semester 1. It is a unit called Congruence, and it's the 7th one of those. And is the second lesson within that called SAS Congruence Postulate Practice. Make sure you're matching up those titles of the video and the problem sets you're working on. This is on creatormath.com under the Geometry tab, and hope this helps.